Welcome, everyone, and thank you for joining us for Coalesce Day 5. My name is Kelly Hora, and I'm a sales director covering APAC for DBT Labs. Though I'm usually based in Sydney, today I'm joining you from Singapore, where the Wi-Fi is, for once, not terrible, but my parents' dog's level of training certainly is. She may or may not interrupt this feed. Let's get moving. I'm super excited to be introducing today's session, Using DBT to Understand Open Source Communities with Srini Kadamati. Srini is a committer to the Apache Superset project and heads up community and developer relations efforts at Preset. Today, he'll be sharing how he and the team at Preset built a fully open source platform that ingests, transforms, and analyzes data to help you understand your community even better. He spent time in San Francisco, Austin, and Boston, where he now lives. And in his words, Boston winters aren't so bad. Honestly, Srini, I don't think I can agree with you there. But after spending a week here in Singapore's humidity, I'd more than welcome some winter air right now. Okay, before we start, a few tips on making the most of this session. The chat in Crowdcast is disabled because all of the conversation is happening on Slack. We're in the Coalesce Open Source Communities channel. If you're not yet a part of our Slack, you have time to join now. Go to community.getdbt.com and sign up. Trust me, you won't want to miss it. Slack is where you can ask Srini all your questions and add comments through the session. He'll also be available in the chat after the session ends. So if you want to chat, ask more questions, feel free to stay around. In case you missed it, Mila has already kicked us off with an icebreaker. What is your favorite open source technology? Okay, without further ado, let's get started. Over to you, Srini.
Awesome. Thanks for the intro. Can everyone hear me okay? Looks like it's working.
Yes.
Perfect. Thanks. Happy Thursday, everyone. Thanks so much for coming. I know it's towards the end of the conference. I was only able to watch a few sessions, but I'm hoping to spend all next week and probably my winter holidays catching up. Usually I'm in Boston, but I am on site in San Mateo, California with the Preset team. You'll have to settle for my MacBook webcam, unfortunately, today. So today I'm excited to talk about how we've been using DBT Preset to understand open source communities. This has been the culmination of over six or 7 months of work now, with a few false starts along the way, but the project is now in a place that's exciting, and I'm here to talk about that today. So I'll start with, I know she gave it a quick intro, but I wanted to go a little bit deeper. So my background's very much in data science and then data science education. I spent 5 years helping scale DataQuest, learned a lot about the challenges that people face when learning data skills using this existing tools. And my general career interest is around how we just spread data science thinking and make those tools and that type of thinking more accessible. So that got me excited to work on making the tools better themselves and bringing some of my kind of education and product experience. So developer advocacy was a nice fit for that, for my next journey, basically. And I'm a committer to the Superset project, which is Apache lingo, means it's silly. It just means you can approve pull requests and give input on bigger changes. But yesterday I was actually just voted into PMC, so I can make kind of bigger contributions and vote on stuff and things like that. So it's been a fun 1.5 year journey for me. And yeah, so just sharing some context essentially. So what is Apache Superset? What is the community behind it? So Superset is a modern open source BI platform. We have a no code and a SQL interface. We work with pretty much any SQL speaking data engine, and we have a large diversity of chart types. The main thing that's, I think, really exciting about Superset and why I joined to work on this is just the open source community is really large. I think we have 40 or 50,000 stars on GitHub. We have a small percentage of those people in our Slack community. We have folks in other places talking about Superset. So coming into Preset and being tasked with, hey, help manage and run this community. Originally, it was just me. So I joined 1.5 years ago. It was quite overwhelming to try to manage and make sense of it all. And that kind of was the inspiration for we call the Community Tracker project internally at Preset. So a little bit of community context, as I mentioned, this was taken last week, so 41,000 stars, bit of a shallow metric, but just providing some context into the scale of the project. A lot of questions on Stack Overflow every week. And then we have some small section of those folks in the GitHub and in other places in our Slack community, which is relatively nascent compared to the DBT Slack community, but it's still a lot for one person to try to make sense of, and then try to provide context and wrangle that context and share it with the rest of the company and start to build programs. Still a lot of work. So that's kind of part of the inspiration for our community tracker project. So I've been talking about community tracker. What exactly is that? And this is the architecture diagram that we like to use. So essentially, we want to understand two things. One, how is our community growing in all the places that community lives? So we have interactions and discussions on Reddit. Our GitHub activities, very large, really high volume. In fact, we constantly hit GitHub API limits for extracting data out of GitHub. Stack Overflow, and we have a Slack as well. And so we want to understand what are the common types of themes and questions people are asking, but also from a personal standpoint, who are active contributors and where are people in their superset journey, and how do we support all of this and really just make sense of it. It's a lot of data, and trying to get insights out of it is definitely challenging. And we also wanted to understand our partner communities. So over the last year and a half, I've been really fortunate to spend time building great friendships and partnerships with over 30 other open source projects. And that's been really fun. And because of the crossover between communities, we also want to understand when people in another adjacent community open a superset issue or want to file a superset bug or talking about the intersection between two tools. And I think this is another kind of part of community that maybe sometimes is forgotten is the community is where people are, not necessarily only the channels that you own. So we're also interested in pulling in data from other partner communities, GitHub projects to look at high level stuff and also understand what they've done from a community standpoint. So this is the result of 7 months of work and iterating, and I'm excited to share some of the journey of the iterations we made here. So we have data pulling into BigQuery. Of course, we're using DBT to do all types of crazy transformations within BigQuery, and then obviously, since we're working on Superset, we're going to use Superset as the kind of front end and BI layer to actually create charts, create dashboards, and try to make sense of and manage this chaos essentially. There's a preview of some of the charts that we've enjoyed creating because of because of the data from the community tracker essentially. So just a nice visual preview here. So first I'll start by talking about the goals here. So first, we want to understand the data tooling ecosystem. It's really large and complicated. My background's more in data analysis and data viz, a little bit of data science. It's not in data engineering. I might work with one or two of these tools before I came in. So if we wanted to do community building, partnerships, ecosystem engineering, all this type of stuff, it was important that the DevRel and community teams actually understand the data tooling ecosystem. And as I learned from my time at DataQuest, the best way to learn is to do. And so we saw the community tracker as a good way of being able to do this. And we're fortunate to be able to touch a good percentage of the tools in this ecosystem, but there's still many that we aren't using. So this was a nice kind of educational motivation for us. Two, as I mentioned and hinted at earlier, we want to understand our own community. So who's actively contributing and what actually drives someone to contribute more? Is it more important to support a small number of people in a high touch way or kind of a low touch way, but scaling it out to a large number of people? And how does that align with the amount of resources and people and time that we have at Preset to actually invest? So I really like using the Orbit model here, which is, I believe now a company. And it's basically for people not in developer relations or community, an alternative to the funnel model where you have people out, they start off as explorers, they're just maybe aware of your project, and your hope is to get a greater percentage of them to being closer to the core, closer to being contributors or builders. I mean, I think DBT is a community that's internalized this really well, and they have a healthy mix of people in every orbit level. And when I joined, we really just had no idea what the distribution was like. Data is one way, I would say, of trying to make sense of this distribution. So this was our second goal. And our last goal was we wanted to build data assets that we could eventually open source and productionize. So my goal here is actually in the next few months is to release all the work that we've done so people can, ideally with a few commands, replicate this entire stack for themselves for their own projects or other open source projects that they're interested in analyzing. What this looks like, I think we're still figuring out. It might be a Docker Compose file. It might be, or it could be the components of the stack as configuration files. What this looks like still needs to be figured out, but this is the three goals that we had. So for the community tracker, I'm excited to share some of the lessons that we have and also talk about the journey along the way. As I mentioned, I'm not a data engineer. It was really interesting to actually understand the whole journey and the evolution that we faced when trying to solve the problems that we had every step of the way. So the first two lessons I wanted to share are one, each abstraction comes with hidden costs and tail risks. So what I mean by that is that this project was actually started by another coworker who has since left, and then I was tasked with taking it closer to the finish line. And so this led, and when it was given to me, there was a decent amount of abstraction, and there was a lot of random issues that I ran into. And I think this is something that I think it's great to have reproducibility, and you want that the scalability. But I do think that we sometimes forget each abstraction does come with these hidden costs. So that was definitely a learning experience for me. And two, getting full visibility into how data is flowing is challenging. I think I love using the command line, but it can be difficult to understand where in the pipeline the error might be and how to really zoom in there and debug it, especially when the error may have actually happened much earlier in the pipeline. So getting that visibility is challenging because most of the humans are good at getting visibility using visualization and BI tools and stuff like that. But that front end of the data is often so late into the data lifecycle that it's hard to use those tools to actually drive understanding when it was in if the problem actually lived in extracting data out of GitHub or extracting data out of Slack. Those tools are not useful for understanding that. So really understanding the full pipeline, each tool in the stack wants to, they might have a data visualizer, but if you want to get full visibility, it is definitely a challenge. I know there's some projects working on trying to solve this, but as it stands, I still think it is very challenging. How did I reach these conclusions? So I wanted to give an overview of the evolution of the stack that we had. So originally, Max, our founder and CEO, he spent a weekend and wrote a fancy, very long Jupyter, a Python notebook, essentially, that did all of the manual extraction from just GitHub at the time. So it pulled in data, and pretty much all of the ELT happened within a notebook. And then we also used Superset for some last mile transformation just for preparing for the visualizations themselves. This was done using a cron job. The data store, however, was a Vertica database that lived on a coworker's local Mac Mini. So needless to say, there's a lot of issues with this type of setup, but this was the type of thing that let us go from idea to implementation in about 2 days. So we got to move very quickly, and that was definitely useful initially for helping us get unblocked. But as you could probably imagine, this had trade-offs. So the first obvious trade-off is that adding any type of new data or updating the schema was very painful because the GitHub notebook was very much, everything was tightly coupled in that code base. So there's very little abstraction there, very little ability to extend it. The Vertica cluster, in air quotes, would constantly go down or be unreachable if the coworker's public IP changed. And 3, it was unflexible. So again, it's hard to add new data sources. However, I do want to emphasize that it was easy to understand. When there was an issue, it's very easy to debug. Everything happened in one tool, pretty much, which was the notebook. And you can debug it easily. You can put print statements, and the Jupyter notebook environment is pretty friendly for trying to make sense of the code. So this is something maybe you don't appreciate sometimes, but this was super. As someone who's not a data engineer, I actually really enjoyed the setup for the first few weeks. The second attempt was, all right, let's overcome the biggest issue, which is the database going down. We'll move it to the cloud. The cloud's supposed to solve all of our problems, right? So we took the notebook, we scheduled the cron job. It's all living in a tiny EC2 instance. The data is now going to BigQuery. The nice thing here is that this BigQuery instance was powering the rest of our analytics internally at preset. So we knew that it was mostly going to stay up most of the time, or we had other problems. So that gave us some nice assurances, and we got over most of the issues there. So to summarize, adding data, though, still very painful, still very inflexible. We didn't fundamentally actually solve any problems with the structure of the data or how it flowed. We just made the maintenance much easier. So it was still easy to understand, easy to debug, and we didn't have arbitrary downtime. So definitely a win, but there's still a lot of work to do. A third attempt here was to abstract away the data extraction from GitHub. So let's not manually manage and tinker that ourselves. So we wrote a few blog posts on our forays into using Meltano and Airbyte. Again, our goal here is to understand, one of our goals is to understand the open source data tooling ecosystem. So using a vendor was out of the question because that would come in conflict with that goal. So we looked into Meltano and Airbyte. I think both of them have their pros and cons. And we hooked up data from those tools. We actually did the transformation in Superset. The data coming out was not too bad. It was relatively clean initially. So we just did whatever query transformation in Superset itself. Cron job, we still had BigQuery, still using Superset for visualizations. And this came with some different set of trade-offs. So one, the big negative was that schema change management was still really difficult without something in the middle, without some type of intermediate solutions. So every time we would slightly change the data that we were pulling out, that we were basically configuring using Meltano or Airbyte, our dashboards would break all the time because there's just nothing to help us manage the schema as they change. However, the good thing here, I would say, that we gained from this abstraction was we now had a flexible system for at least adding new data sources, even if we couldn't do too much about versioning and iterating on the data sources individually, being able to spin up new data sources and new pipes, new extractors from third-party sources. Because Meltano and Airbyte are pretty good at this, this at least gave us more flexibility here, which was great. Now, the next attempt was we finally were looking for an excuse for DBT, and we decided to start investing in just that. And so, as you can see, we were at every step of the way trying to understand the concrete problems we had and how to introduce abstractions and tools along the way to solve the real problems that we had. So pretty much everything else stayed the same, except now we were using DBT for all of our models. So that meant we had to go spend a month learning how that worked. So Max and I spent a month doing that. And that was a really fun journey. And we also moved to using Jenkins instead and using a little bit more of a regular CI process instead of just a cron job. And everything else stayed the same. And we got a lot of benefits out of this. So now what we can do essentially is it's very quick to add any new source and no dashboards break. So for GitHub data, we're using Airbyte right now. So if we wanted to add a new repo, let's say we wanted to compare ourselves against another competitor's project, or we just wanted to add more adjacent partner projects, we can, with a few clicks in Airbyte, accomplish the data extraction, wait till the job finishes, and then in DBT, we just need to add 3 lines in our GitHub repos section, in our profiles.yaml file. We do dbt run to test it, and basically within a few minutes, we've onboarded a new data source, and no dashboards actually broke, which was actually a big deal because also the way that we're creating the dashboards has changed, thankfully, so they can accommodate new types of repos and data sources from the same third party place without actually breaking things. So that was a welcome change. So we're now in this land of getting closer to kind of data as code and the kind of data ops movement. So this was the culmination of 7 months of work that we've done. We're now at a place where we can actually scale this up and begin to think about open sourcing it. So this had its own set of trade-offs, right? So one, definitely increased complexity. It became much harder to debug. Every step of the process now had way more abstraction. More of majority of the code was written by people that weren't us. Compare that to the notebook example, in where we wrote pretty much everything. Is less friendly for beginners. As I mentioned, I inherited this project, and it took a few weeks to really learn parts of the pipe that I was not familiar with. So the air by part, I didn't have a ton of exposure to. So I had to spend a lot of time learning that. And as related to both of these, it's much more abstraction. So with that kind of goes hand in hand with the increased complexity. But yeah, so we later learned this issue that I mentioned earlier about GitHub rate limiting us for certain repos, but not for others. But the way that was presented to us were these Airbyte specific Java error messages that we didn't have much familiarity with. So this definitely kind of introduced new tail risks into our pipeline. If GitHub decided to change their API, we would have to wait for that part of that abstraction to catch up and address it while we sat around. So definitely more complexity here. In our case, I think the trade-offs are worth it. So what we get out of that is more portability. So it's much easier to open source and productionize the work that we've done. So when this type of project and the work here is actually business critical, we can hand it over to the infra team and work with them. And as I mentioned, we can add a new data source in under an hour. This is really powerful. So some of the other lessons that I've learned through this project were number three, Superset really needs a DBT integration. I suppose at this point, that's become very common for pretty much every data tool out there. But I think, especially when I was syncing data, running models, and trying to understand the downstream impacts of that, having to look in 3 or 4 different places was pretty frustrating. And I really was dreaming for better syncing between the tools. Even simple stuff like when was the data actually last updated and transformed to know if the front end is aware of the changes. And two, there's a lot of great metadata and schema information in the models themselves. The front end, the BI layer should be aware of it. Four, heavy amount of unbundling happen up and down the space. So I think the most interesting thing that people are talking about now, which I was able to experience firsthand, is the BI layer is definitely splitting into many components. We started moving all the transform logic out of the superset semantic layer and into DBT. Now you have people wanting to do that with the metrics layer. So you have DBT, and then your kind of front end of that is a metrics layer like Cube or metric QL or transform. So it's splitting into a lot of components. As they say, everything is about unbundling or bundling. So I think we're very much in the phase of unbundling a lot of the stuff that was grouped together in the BI layer. Second subpart here is that the glue between components is increasingly becoming important. I think this is obvious when you look at a lot of the integrations between tools, that the kind of n squared number of integrations that need to happen. Also why I think DBT and Superset, need an integration here. And lastly, I think open source and unbundling will enable data mesh like setups to work. So I know this is a hot buzzword nowadays, but I think if you are going to, the only way this type of decentralized microservices first approach to managing data in an organization could work is if you have this amount of unbundling, because that is the only way that idea will actually manifest. Otherwise, you're stuck with a single pipe. You have a single point of failure, which could be somewhere in the data stack. It could be the BI layer. It could be where your ELT is happening or your data store. So if you only have one heavy vertically integrated option, you can't get this type of distributed, microservice design for your data stack. Lastly, everything will be version controlled. I think I never became more convinced than I have doing this project that everything eventually will become version controlled. People call this data ops sometimes, but I think definitely DBT was a pioneer here. But it's cool to see more tools exposing the final data assets as kind of flat files that can be checked into version control. And this honestly is the only way that we will be able to open source all the work that we've done for anyone to replicate and use is if it is in these version controlled files that are accessible. And actually, the other lesson is that even though we've talked a lot about the architecture here and the evolution here, by far the biggest bottleneck in many ways is still getting data out of APIs themselves. So if there isn't a connector, you're out of luck. It's hard to build something and then deploy that alongside Multana or Airbyte deployment. It's a lot of work. And lastly, you hit API throttle limits for larger repos, as I mentioned earlier, pretty easily. So we can't currently extract every single comment for every single issue for Superset and some of the larger repos as well. So this is still a big problem, but that was something else that we learned through the project. Kind of wanted to end by talking about where DBT shined. So definitely enabled the BI layer, in our case Superset, to maintain a very consistent schema, because as data was being pulled out of sources, we could still enforce that the final data structure touching Superset was consistent. To enable new data source to be added and standardized easily, with just basically DBT is able to turn SQL into a little bit more of a dynamic language, and just through some basic config changes, we can easily onboard new data sources. And lastly, we are able to enable more collaboration on complex nested data transformation. So we have another community engineer that's able to work on their own DBT model. We can merge that in and we can collaborate much more easily than we could in the past. So that was these are the overview of the work that we've done. And I'm hoping in the next, by February, hopefully to open source the work that we've done so anyone can replicate it on their own. And thanks for coming. Happy to take any questions in the Slack.